This video will cover the topic solving a word problem using a quadratic equation with irrational roots. In order to use a quadratic equation to solve a word problem, we first write our equation in standard quadratic form and then use the quadratic formula to solve for our variable. Let's break that down. A standard quadratic equation is written in the form 0 equals ax squared plus bx plus c, where a, b, and c are real numbers and x represents some variable. When we have an equation written like this, we can use the quadratic formula to solve for our variable, which is x in this case. The quadratic formula looks like this. X, or whatever our variable is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c in this formula are the same a, b, and c in our original equation. This formula can be very useful whenever we need to solve for the variable in a quadratic equation. Let's do an example. Suppose a model rocket is launched with an initial upward velocity of 138 feet per second. The rocket's height, h, after t seconds is given by the following equation. H equals 138t minus 16t squared. Find all values for t for which the rocket's height is 78 feet. We want to find at what time the height is 78 feet. So, where should we plug the number 78 into our equation?
Well, 78 feet is the height, and the problem states that h stands for height. So, should we replace h with 78?
Exactly. We replace h with 78 and get the new equation 78 equals 138t minus 16t squared.
So now we can use the quadratic formula?
Well, first we need to write this in standard form. The quadratic formula only applies if our equation is set equal to 0, like we discussed at the beginning.
Could we subtract 78 from both sides to make that true?
Right. We can subtract 78 from both sides of our equation so that now it looks like 0 equals 138t minus 16t squared minus 78.
So now we can use the quadratic formula, where a is equal to 138, b is equal to negative 16, and c is equal to negative 78.
Not quite. The last thing we need to do now to put this in standard form is to order our terms from highest degree to lowest, meaning our term with t squared should go first, then the term with t raised to no exponent, and then the term with no variable.
So we have negative 16t squared plus 138t minus 78.
Right. Now that we have our terms ordered from highest degree to lowest degree, we can use the quadratic formula to solve for t, our variable.
So a is equal to negative 16, b is equal to 138, and c is equal to negative 78.
Exactly. Now we can use the quadratic formula. When we replace x with t, our new variable, and a, b, and c with the values that we found from this example equation, our quadratic formula looks like t equals negative 138 plus or minus the square root of 138 squared minus 4 times negative 16 times negative 78, all divided by 2 times negative 16. We can simplify this to t equals negative 138 plus or minus 118.541, all divided by negative 32.
How do we calculate that plus or minus sign?
The plus or minus symbol means that we should calculate this once using addition here and once using subtraction. We may end up with two different answers.
How can there be two answers?
Remember that our original question is asking about the height of a rocket and at what time it will have a height of 78 feet. Since the rocket goes up first and then comes back down, it could have a height of 78 feet at two different times, once while it's rising and once while it's falling.
Okay, that makes sense.
So let's calculate t when we have a plus sign here first.
Using my calculator, I got 0.61.
Great, now let's try replacing this with a minus sign.
This time, I got 8.02.
Awesome. So our answer is that the rocket's height is 78 feet when t equals 0.61 seconds or 8.02 seconds.
I think I get it now. When we use a quadratic equation to solve a word problem, we first write our equation in standard quadratic form, and then use the quadratic formula to solve for our variable. There might be two answers.
That's right.